Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an interesting complex equation. I call this equation interesting because when you see what I'm about to do to the equation, I think you'll be a little surprised. Maybe you've already seen it. Please don't give it away, okay? And I'll just be presenting two methods, and the first method is called the painful method, okay, which we may not complete, but I still want to show you how that works. Okay, so my first approach would be to replace z with something. Since z is a complex number and the name of this channel is A plus BI, which is important, right? Then I'm gonna set z equal to A plus BI, where A and B are real numbers. If you're new to complex numbers, go ahead and check out my lecture videos. I made playlists on lecture videos, easy problems, hard problems, medium problems, and also let me know what you think about the difficulty level, because sometimes I mismatch, and if you think a problem that I labeled as medium is hard, let me know. I'll try to, accommodate that. Anyways, z equals A plus BI. Let's see what that's going to give us. Plug it in everywhere, and now we're going to get something like this. But before that, should I cross multiply? Maybe not. Okay, let's not do it. That's okay. Let's just plug it in directly. A plus BI squared plus A plus BI plus 4 is equal to 2i minus A plus BI cubed. I'm going to expand it next, maybe after I cross multiply, right? So let's go ahead and expand it actually. I'll probably cross multiply a little later. 2abi plus A plus BI plus 4. And then this is cubed. I forgot to write that 3 there. And when you cube it, you're going to get something like this. A cubed minus 3ab squared, because I cubed is negative I and I squared is negative 1. We kind of have to make sure we find the real parts and imaginary parts separately, like this. Oops. Just messing up the writing. 3a squared b minus b cubed. And all of that is multiplied by I. And of course, the whole thing is subtracted from 2i. So you got to be careful. You're going to, that's not distributive property, but you need to distribute the minus sign, okay, sort of. And then when we go ahead and multiply everything together and kind of arrange these terms a little bit, this is what it's gonna look like, okay? We're gonna get 3a squared after cross multiplying minus 3b squared plus 3a. A is going to be multiplied by 3 and 4 is going to be multiplied by 3. It's going to be here 12. So this is the real part. If you want, you can put that in parentheses. You don't have to, but it kind of helps sometimes. Plus, the imaginary part is going to be coming from here and here. And you can kind of write it as 6ab plus 3b. And of course, multiply by I. And that's going to equal what's in the numerator, which is the complex number 2i minus z cubed, right? And that's going to be minus a cubed, once we, distribute, plus 3ab squared. And then plus, we're going to have the same expression inside the parentheses, but this time it's going to have a plus sign. Actually, never mind. That's supposed to be a minus sign, because when I distribute it, right, this minus sign over here, it should turn that into a plus sign. It did turn the other ones, so it should turn this one too. So I should change it to a minus sign. Awesome. Now it's good. And here's where, when we compare the real parts and imaginary parts. So this should equal to negative a cubed plus 3ab squared. And this should equal the opposite of this expression, which I can negate and write it as follows, because that's going to be a little easier to handle. So that's what I'm getting. So that means I have two equations, which is a system, and there are two variables. Hopefully, I'll be able to solve the system. The problem with this system is it's cubic, so it could be a little painful. But the good thing is it's going to be homogeneous. Now, what do I mean by that? Actually, never mind. It may not be. I was just focusing on these guys here, but this is probably not going to be homogeneous, which could be very problematic. That's why this method is probably going to be left incomplete. But if somebody wants to go ahead and solve it to completion, that would be awesome, and let us know what you're getting. But let me kind of show you some of the things that we can do. While we kind of have this system and then the other equation is going to give me the following. The second equation looks more friendly to me because of the maybe I don't know, just the numbers and the way it's given. So this is 3b. Those are the imaginary parts, and I negated the imaginary part, so it should be good. Okay, all good. Now, this is our system, and how do we solve it, right? That's the million-dollar question. Now, there's a couple things you can do. You can try to solve for one of the variables, which again, that will be really hard because a and b both appear as a cubic, a quadratic, and linear. So that will be really challenging. But you can try to maybe, okay, here's one thing I can think of. Maybe I can just multiply one of these equations by a or b, and then add or subtract to the other one. Maybe I should be able to eliminate one of the cubes, in which case it will be good. At least we're going to be solving a quadratic. But no matter what you do, this is going to be super messy. If you want to take the challenge, go ahead and take it and let us know what you find. That will be pretty interesting. Anyways, this is the first method. Let's leave it at that and move forward the second method, okay? Because the second method is definitely much nicer, and kind of people get mad when they see like, oh, this is not fair. That's the usual reaction, like, oh, come on, this is so contrived. That's what happens with competition level problems. They always have a trick. And obviously, this is not too complicated because a lot of people are not going to use the first method. You know why? Because most people are going to cross multiply. And they may stop at that, but let's do it. When we cross multiply, we get 3z squared plus 3z plus 12. And then that is equal to 2i minus z cubed. Do you think we want to leave z cubed alone? No. We want to put all the z's on the same side and maybe everything else on the other side. So let's go ahead and add z cubed. Does that look familiar? Hopefully it does. And subtract 12. And this is what we're going to get. Now, this is not the best thing to have. And I hope I didn't mess up the numbers because I was trying to make this problem solvable. Hopefully I didn't mess it up. So now the next thing I want to do is, I'm looking at the left-hand side, right? And that looks like a perfect cube, but it's missing something. What is it missing? It's missing 1, right? Because if you add 1 to both sides, what's going to happen? We're going to get a perfect cube. That is z plus 1 quantity cubed. So what I need to do then is just add 1. So it's going to leave some room here for the addition of 1 to both sides. And here we go. Now look at the left-hand side. Isn't it z plus 1 cubed? Yes, it is. That was the whole trick. Now I kind of gave it away, but let's go ahead and complete this problem, right? So what does that mean? It means that I have a perfect cube and I can just cube root both sides. But this number has 3 cube roots. Which one am I going to find? Well, I guess the first one first, because once you find the cube root, the others are easy. So at this point, you're going to cube root both sides. And obviously, this is not the right notation. But if you raise both sides to the power 1/3, maybe that'll be more appropriate. But this is what we're going to get. The cube root, all the cube roots, by the way, are going to work. So all I have to do is cube root this number. But how do you cube root a number? That's a good question. And this kind of requires another set of operations, such as you can go ahead and set this equal to something like x plus yi. And I'm using it because a plus bi was already used. Sorry, a plus bi. And now you can cube both sides and go off of this. So if you cube both sides, you're going to get x and y, or some equation. It's going to be x cubed, and again, remember, this is going to give you plus 3x squared yi, and if you just kind of just copy off of the first idea, it's going to look like this. So you're going to get something like this, okay? And this is equal to negative 11 plus 2i. So by setting this equal to negative 11, by setting this equal to 2, you're going to be able to solve for x and y, and then you can basically find one of the cube roots, right? Let's go ahead and solve it. Let me show you how I can solve these kinds of systems, because this one is homogeneous, okay? Now, here's what we're going to do. We're going to go ahead and replace y with something. How about y equals ux? Awesome. You can use any variable you want. Now, when you do that, you're going to get x cubed minus 3x multiplied by u squared x squared, which is going to give us x cubed minus 3u squared x cubed equals negative 11. By the way, substitution didn't change the number on the right hand side. And here we're going to do it 3x squared times ux minus u cubed x cubed. And that's going to be 3x cubed u minus u cubed x cubed equals 2. Now here's when we use factoring. We're going to take the x cubed out. 1 minus 3u squared, x cubed out, 3u minus u cubed. And then set it equal to this. Divide both sides by that. And x cubed is going to cancel out. And you're going to get a cubic equation. Let's go and cross multiply. Negative 33u plus 11u cubed equals 2 minus 6u squared. If you put everything on the same side, 11u cubed plus 6u squared minus 33u minus 2 equals 0. And we might even factor this equation. I'm not sure if it's factorable. It might be, may not be. But if you take out 11u, then I think we're going to get u squared minus 3. And then from here, if we factor out a 2, we're going to get 3u squared minus 1. So that didn't work. Maybe another way to pair these up is going to work, but I'm not seeing it. So let's go ahead and just proceed with the normal solution. So what can you do from here is basically use the cubic formula or use the rational root theorem. And possibilities are you can get plus minus 1 plus minus 2 all over 11. So those are going to be the possibilities. Once you find the u value, you can go ahead and plug it in here and then substitute. Or another way to do this, the cube root of negative 11 plus 2, let me just quickly show you. Since this is a negative number, I'm just guessing if my number is like x plus yi, as x is probably going to be a negative number. And I'm just going to be guessing, okay, could this be something like negative 2 plus I? Or negative 1 plus 2i, or something like that. You can go ahead and cube these numbers and see if these are going to work. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.